All right, so we're in the last chapter of geometry. I know, can you believe it? And we're talking about things that you've already seen before. Today we're talking about area of different polygons. So you know that a square has all four sides congruent. The formula for area of a square is area equals the side squared. So if the side is 6, what would the area be? Well, you'd have to do 6 to the second power, or 6 times 6, which is, yep, 36. Likewise, if I know that the area is 49, ask myself, what times itself equals 49? 7 is the answer. A rectangle is a special kind of square, and we find the area of the rectangle by doing the base times the height. And the base and the height, you have to remember, are found where a right angle is made at the intersection of two sides. So in this shape, I look for my right angle. 3 and 6 are my two sides. I multiply them together. What is 3 times 6? 18. I use that same formula for area of a parallelogram. The properties of quadrilaterals tell you that a parallelogram does not have necessarily right angles at the corners, but it has two pair of opposite sides that are parallel and congruent. So I look for where the height is and where the base is, and I find them by where the right angle is formed, multiply them together. What's 8 times 2? 16. In this particular parallelogram, the height is formed by dropping a perpendicular to the exterior of the parallelogram. I know that my base is 7, my height is 4. I don't worry about this part over here as part of the measurement because it's just there to help me make my right angle. 7 times 4 is 28. Now if I took this parallelogram and I drew a diagonal, I would have two different triangles. So if I knew the area of a parallelogram and cut it in half, I could find the area of a triangle. And that's where my area of a triangle formula comes from. It's equal to half the base times the height. Again, look for the right angle. 5 times 2 is 10. Half of 10 is 5. Now a rhombus has a pretty bizarre formula for area. I take the two diagonal lengths, I multiply them together, and then cut them in half. And I could explain the proof to you, but it would take a long time, and you don't really care. So let's just use the formula. E is 10, BI is 9. Multiply the two diagonals and you get 90. Half of 90 is 45, and you're done. Two more formulas. Area of an equilateral triangle. Again, there's a long proof to get you to this point. We're just going to apply the formula. Since all three sides are the same, I'm going to take my side and square it. 12 squared is 144. Square root of 3 over 4. And I have to simplify this bad boy. 4 goes into 144 38 times. Sorry, it took me that long to figure it out on the square root of 3. Last one, area of a trapezoid. Area equals half of the height times the sum of the bases. 6 plus 10 is 16. Height is 4. Multiply times a half. Half of 4 is 2. 2 times 16 is 32. The only thing that's missing from all of these problems are units. If this was centimeters, then my units would be centimeters to the second power, because when I'm talking about area, I'm talking about square units. Make sure that you always include the exponent. When you go to take standardized tests, they would give you 32 centimeters squared, and they'd expect that you'd know that the area is the one with the exponent of 2. Time to do your assignment.